Hi, welcome to my new tutorial. In this video, I will show you how to create your own personal avatar out of a single photo. We will then turn our avatar into a 3D model and make it walk, just like a real person. And of course, we will make our avatar talk, as you can see here. So let's get started.
For this tutorial, I went deep down the rabbit hole to give you a comprehensive and practical guide on the whole process of creating an avatar of yourself or any other person you like, even a totally fictional one. Please act responsibly when creating an avatar of a celebrity or a public figure. This guide is divided into chapters, so you can skip any steps you're not interested in. In the first chapter, I will show you how to build a ComfyUI workflow that will create high-quality images of your avatar that are stable and consistent, using only a single photo as an input. I'm going to use several IP adapters and an SDXL-Lightning model, which takes only 4 steps to render. By the way, you can download all my workflows for free, link down below. The second chapter is about creating an animated 3D model out of your avatar images using the free Avaturn website. In order to do that, we need to create 3 avatar images from different angles, which will be shown in my second workflow. Then we will import the 3D avatar into Blender and create a little scene that will be used as an input for ComfyUI. In the next chapter, we will extend our ComfyUI workflow and use AnimateDiff to create a flicker-free walking animation. Then we will use FaceFusion to improve the quality and coherence of our animation even further. In the next chapter, I will show you the DreamTalk AI script to let our avatar talk, and use FaceFusion again to improve the quality. And in the last chapter, I will show you how to use my little Python script to download all models and checkpoint files used in this tutorial automatically. You see, there's a lot to show, so let's get right into it. Starting with the standard ComfyUI workflow, let's first select the SDXL-Lightning checkpoint. In my case, it's the Juggernaut SDXL-Lightning 4 steps model. We will use a fixed seed to get reproducible results. Any seed will do. We reduce the steps to 4 and the CFG scale to 1. Now that's important. The sampler needs to be Euler and the scheduler must be set to SGM uniform, or it won't work. With only 4 render steps, the SDXL-Lightning model is very fast, so we can set a high image resolution. Let's go with 1344 by 768 pixels, which is one of the standard SDXL resolutions. Now we need a load image node for the photo, which we are going to turn into our new avatar. The photo should be a close-up facial shot, with the whole face and some of the background visible. It's best to use a square image, but we will crop the image to the required sizes for the IP adapters in a next step. Next, let's get an Apply IP Adapter Face ID node for our first IP adapter. It's quite a powerful node, and it will bring us one step closer to our avatar. Let's connect the model and then add a Load IP Adapter model node. We need to select the Face ID plus V2 SDXL model to make it work with our SDXL checkpoint. Let's connect those two and set Face ID V2 to true. We leave the rest of the settings at their default values. Now we need a clip vision loader with the B97K clip model and a load InsightFace node set to CPU. GPU doesn't seem to work yet. Finally, we need a prepare image to InsightFace node to crop our input image to the right size. Let's connect it with our image. We can also add a preview image node to see what's happening. Looks good. Now we need an Apply IP Adapter node. Connect it to Clip Vision. Let's also duplicate the Load IP Adapter model node by pressing the Alt key and dragging it down. Now select the full face SD15 model. It's a 1.5 model, but it works just fine with SDXL. Let's connect it. We also need an image crop node to crop our input image to the right size for the IP adapter. The face should be centered and fill the whole image without showing any background, and it should also be square. Let's tweak the settings until we get the best result. Then connect the cropped image to the IP adapter and connect the Face ID model output to the IP adapter model. Let's reduce the weight to 0.6 and set the starter value to 0.3, so the influence of the IP adapter on the rendered images will be reduced. You can play around with these settings and look what difference it makes. I would also recommend using a LoRa node to further enhance the Face ID IP adapter. Set the weight to maybe 0.6 to reduce its influence a bit. Then connect the IP adapter model output to the LoRa input and the LoRa output to the K-sampler model input. Now we just need a positive and negative prompt to describe our scene. Just keep them as simple as possible. It doesn't need that much. Let's render our first image. The first run might take a bit longer because the models need to be loaded into the GPU memory, but any further renderings should be blazing fast with only 4 render steps needed. Now here's what we've got. Looks perfectly similar to our input model, doesn't it? Finally, I want to add an image upscaler and refiner to improve the size and quality even further. But first, let me clean up the workflow a bit to make it less messy. Let's add a hires fix scale node and connect it to the VAE image output. I will set the rescale method to width and height and set the size to 1920 by 1080 pixels. Now let's duplicate our K-sampler with Alt-drag, enter a different seed value, and connect the IP adapter model to the model input. Also connect the positive and negative prompts and connect the hires fix scale latent output to our K-sampler latent input. Finally, let's duplicate the VAE decode node, connect it to our second K-sampler and the VAE, and connect the image output to the save image node. That's it. Now let's render again. Okay, that's not what we've expected. In order to get a consistent image, we need to turn down the denoising strength of our second K-sampler to a lower value, let's say 0.4. Now let's render again. That's much better, isn't it? Now we're done with the first part. We can use different prompts and you will see that the generated images stay very consistent with our single input photo while the scenes are nicely following our prompts. We've created our personal avatar and can generate any scenes we like. But that's just the first step. Let's go to the next chapter and take it much further than this. Wouldn't it be nice if we could turn our newly created avatar into an animated 3D model? That would offer us a great variety of new opportunities. We could place our avatar into a 3D scene, move around the camera, and render it from any angle we like. Well, that's possible, and actually it's not even that hard. So let's give it a try. There's a free website called Avaturn, where you can create a quite realistic avatar using only 3 photos, taken by a webcam or via upload. Link down below. First sign up with your email address or simply sign in with Google if you have a Gmail account. Once that's done, you will be asked to scan a QR code with your smartphone and take some photos in order to create a 3D avatar. That's not what we want in our case. We would rather like to use the avatar that we've just created with ComfyUI. Still, I guess we have to go through that process once before we finally get access to the upload images function. So bear with me for a moment. So pick up your smartphone, scan the QR code with the camera, then open the link presented and follow the instructions of how to create the avatar images. Once that's done, go back to your PC and you can see that an avatar of yourself is created. Still not what we want, but we are nearly there. I hope they will optimize that process in the future, but overall it's not that difficult, and it's worth it. Okay, Here we have the avatar, which actually doesn't look that good, but we won't need it anyway. Hit the back button, and on the upcoming screen you can see that there's a button called New Avatar. Click on it, and on the next screen you will find the option Upload Form Device. Click on it. As you can see, we need 3 photos of our avatar, one from the front, one from the left, and one from the right, which should be in an aspect ratio of 3:4 or 9:16. So let's do this in ComfyUI. First, let's calculate our new image size. It's 1344 divided by 4 times 3, so the width will be 1008 and the height 1344 pixels. Let's change the size of the latent image accordingly. For the upscaler, it's 1920 divided by 4 times 3, which gives us a width of 1440 and a height of 1920 pixels. We could also do this with a math node, but I'm too lazy for that. Now we need to generate the 3 facial shots of our avatar from different angles, and for that we're going to use an open pose control net. Let's add an apply control net node, connect it with the positive prompt, and connect the conditioning output with the positive input of both K-samplers. Then let's connect it with a load control net model node and select the OpenPose XL model. Now we need a load image node for the OpenPose image. I've already prepared the required OpenPose images, so we won't need a preprocessor to generate them. I will provide a download link for these images, so you won't have to bother generating them yourself, but if you're interested in how to do it, I will leave a link to one of my previous tutorials, where everything gets explained in detail. We also need to change the positive prompt a bit, because we need a neutral background as shown at the Avaturn website. Then let's render the first image. Let's save it to a location where we can find it. Then let's select the OpenPose images for the 2 other poses, render and save them. Now back to Avaturn. Just drag the 3 images of our avatar that we've just created onto the respective input boxes and also select the gender, in our case, female. Then you can choose which type of avatar you want to create. We will just go with the regular one without face animations because we're going to use a different method for animating the face and let our avatar talk. Then hit the Submit button and wait for your 3D avatar being created. Once it's done, select the right body type, hairstyle, and hair color. Then choose which kind of clothes and shoes your avatar should wear, and we're almost done. We could now export the avatar as a GLB file and animate it manually or with the help of Mixamo. But there's even a better option if you don't need very sophisticated and complex animations. Just click on the Animate button at the top right and select one of the pre-built animations and poses. I will just make our avatar walk. Now let's click on the Download button on the bottom left of the main window and export it with animation onto your local drive. We're finished with Avaturn, and in the next step I will show you how to use our 3D avatar in Blender and then bring it back into ComfyUI. So let's head over to Blender and open a new general project. If you're not familiar with Blender, it can be a bit intimidating at first sight, but just follow my steps and you will get along just fine. I've activated screen keys because much work in Blender is done by using shortcuts. So in the bottom left of the screen, you can always see what I'm just doing. Let's first delete the default cube by clicking on it and pressing the X key. Then hit File, Import, GLTF 2.0 and find the GLB file of our avatar that we've exported from Avaturn. Zoom in and get your view into the right position and switch to viewport shading mode so you can see the fully shaded model. When you hit the play button down in the timeline, you can see that the animation has also been imported, but it stops after a few frames. Let's fix that. Drag up the bottom window a bit and head over to the nonlinear animation editor. Click on the push down button to convert the animation into an NLA strip. Then hit N to show the animation window on the right side, expand the action clip section, and enter a value of 10 into the repeat field. Now the animation will be repeated 10 times. Switch back to the timeline. Now bring the view into the position that you want to be rendered. Then from the menu bar select View, Align Active Camera to View. The box appearing on the screen is the camera view. Now select the camera in the right window, hit G and move the mouse to get the camera into the exact position which you want to be rendered. Now that's it for the avatar, but I also want to add a little background scene to make it look more interesting. So let's head over to Sketchfab, where you can download thousands of 3D models for free. Let's look for an alley, then select the one you like, click on Download 3D Model and download the model with the GLTF format. Once it's downloaded, unzip it and then let's go back to Blender. Now let's import the model into our scene. It's too small for our avatar, so hit S and drag the mouse to scale it up. Let's switch to wireframe mode so we can still see our avatar, although it's hidden by the alley. Move the model around and rescale it further until we have the right position and size. In case that's all a bit too complicated for you, I will attach the final Blender file to this tutorial, link down below. Once you're satisfied, switch back to viewport shading mode and click on the little camera icon to activate the camera view. Now when we hit the play button in the timeline again, you can see that the avatar is walking correctly, but it always stays at the same position, which makes it look a bit unnatural. Now we could tweak the walking animation to fix that, but I'm going to choose an easier way, by just moving the alley while our avatar keeps walking. So let's select our alley again, which is the Sketchfab model object in the right window, switch back to wireframe mode, and drag the alley to the desired starting position. Also make sure that you are on the first frame in the timeline. Then, in the main window, hit N to show the transform window, hover your mouse over the location parameters, and hit I to insert a keyframe. Then move to the last frame in the timeline, drag the alley to its desired end position, and keyframe it again. Now the animation looks more realistic. Now before we export the animation, let's add a point light to the scene by pressing Shift-A and move it to a position where the avatar is well lit. Finally, let me do some final tweaks with the camera, and then let's render the animation. Click on the Output button in the right window, check the resolution and frame rate, select the output folder and the file format. In my case, it's MP4. Then in the main menu, select Render, Render Animation, and wait until it's finished. So here we have our rendered animation, which we will now feed into ComfyUI as a video-to-video input. Back to our Comfy workflow. Let's add a load video node and load our Blender animation. We will downscale the video just a bit, so let's get an upscale image node and set the size to 1344 by 768 pixels. Next, we bring the image into latent space, so we need a VAE encode node and connect it with our VAE. As we're creating a video-to-video workflow, we connect the VAE latent output to our K-sampler latent input. We also need to reduce the denoising just a bit, say 0.8, so our input video gets some influence on the rendering, and we need an apply AnimateDiff model node to make it more smooth and stable. Let's also get a load AnimateDiff model node with an SDXL model. Next, we need a use-evolved sampling node connected by the M model, and because our animation has more than 16 frames, we also need a context options looped uniform node. I will also add a free U node, which improves the quality and colors without any further costs. Now connect the model output of our IP adapter LoRa with the free U model and the free U model output with evolved sampling model input. Let's also adjust the free U values. You may play a bit with the values, but overall I think that my settings are good for our case. Now connect the use evolved sampling node output with the model input of our K-sampler. I'm doing this via the reroute node. Unfortunately, we need to get rid of our upscaler and the second K-sampler because the video generation requires a lot of hardware resources at a high resolution, but I will show an easy way how to improve the video quality in the next chapter of this tutorial. We also need to add a video combine node, because the output will be a video, not a single image. And I will also add a Rife video interpolation node to make the animation smoother. Just put it between the VAE decode and the combine video node. Let's also select the Rife 49 checkpoint. Now to the control net. I'm not going to use the OpenPose, but the Canny control net, and since we need to extract it from our video frames, we also need a Canny Edge preprocessor to generate the control net images. Let's connect them with the video frames output. Then I want to add a depth control net, so let's duplicate the control net nodes and add a depth anything preprocessor. I'm also going to reduce the control net weights to 0.6 to give more leeway to the other components. Let's connect everything properly and we are ready to render our animation. First, I'm going to do a test run with just 16 frames. Okay, not too bad. Think we're nearly good for the final render. Now let's render the full animation. Depending on your hardware, it might take some time, and maybe you will also need to reduce the video size via the upscale image node. Okay, we ran into an error, so let's try to solve it. If our animation has more than 16 frames, we need a load advanced control net model node. The standard one doesn't work, so let's change that. And then let's render again. Okay, here's the final animation. It looks smooth and stable, but it's still not perfect, because we were limited by our hardware resources. So how can we improve our video? There's a very sophisticated AI tool called FaceFusion, but, to my knowledge, it's not yet a part of ComfyUI. But there's an easy way how to install and run it on your local machine. Have you ever heard of Pinokio? It's a free tool for running various AI applications in a virtual Python environment. I think it's extremely useful, and there are lots of interesting free AI apps included, even ComfyUI. So let's download and install it if you haven't done so yet. Everything is explained very well on their website, so it won't be a real challenge. I'll leave a link down below. Once you've installed Pinokio, search for FaceFusion and download it. You will then ask to install it, so just do it and be patient, as it can take a while to set up the virtual Python environment. Once that's finished, just launch the app. That also might take a while at the first run of the app, as some large models and checkpoints need to be downloaded. I've already done it, so it's going to be fast. When it's done, click on the link to open the app in your browser. It's very simple to use. Just select the options you need. In our case, it's Face Swapper, Face Enhancer, and Frame Enhancer. Load a facial image of your avatar into the source box, and then load our ComfyUI animation into the target box. If you've got an NVIDIA GPU, you should also select CUDA, as it speeds up the rendering considerably. You can play around with the other settings, but I think the default values are just fine. Now just hit start and the animation will render. The face swapper tries to replace the face with the original avatar photo, which takes it even closer to what we want. The face enhancer tries to enhance the quality of the face even more, and the frame enhancer tries to improve the overall quality. Now here's the final video. You can see that the quality and the likeness of our avatar has improved considerably, and it wasn't really hard to achieve. There's one thing left. I want our avatar to talk. Now there are several options. I've already posted a tutorial about Sad Talker some time ago, and there's even the LipSync option in FaceFusion, but I wanted to try something different. So here we go. We're going to install another app in Pinokio called DreamTalk, so go to the Discover section and find it in the list, then download and install it. Again, that can take some time. Once that's done, just launch it and wait until the models are downloaded. Then click on the link to open the app in your browser. It's very simple. Just upload your avatar image into the image box and an audio file into the audio input box. Any MP3 will do. I've just created a short talking sequence with a standard voice in 11 labs, which is free up to a certain amount. Then hit run and wait until it's finished. Shouldn't take that long. Okay, here's the result. The lip sync is great, but the quality isn't. But we already know how to improve the quality, don't we? Just download the animation and then let's head over to FaceFusion again. Bring the Pinokio app to the front and stop DreamTalk. Then hit the home button and start FaceFusion. Now again, load our avatar image into the source input box and the DreamTalk animation into the target box. Then select Face Swapper, Face Enhancer and Frame Enhancer and hit Start. And here's the final video.
Hi, welcome to my new tutorial. In this video, I will show you how to create your own personal avatar out of a single photo.
Now we're nearly finished, but I've got another goodie for you, which might save you some time if you want to try out my workflows. Down in the description of this tutorial, you will find some download links with the workflows, a zip file with the input images and videos, and the Blender file where I built the 3D animation. There is also a zip file called Download Models, which includes a little Python script that will download all missing models and checkpoints used in this video and a JSON file where these models are listed. I've made a clean ComfyUI installation to show you how to get everything running from scratch, because I know it can be a pain when you want to run a workflow written by someone else and some things are missing or just aren't working. Let's drag the first workflow into Comfy, and you can see that there are some missing nodes. Just install them with the ComfyUI Manager, install missing custom nodes as usual. After installing and restarting, all nodes are there, but there might still be things missing. I'm using an SDXL-Lightning model, some LoRAs and other stuff, and usually you might need them download manually from different places and sites. So I wrote a little Python script that will do the hard work for you. Unzip it and copy the get_models.py and models.json files into the ComfyUI subfolder of your Comfy installation, one level above the models folder. Then open a command window there and run the script by typing python get_models.py. When asked for the file name, enter models.json and hit enter, then confirm the downloads and all the missing models will be downloaded into the right folders. That will take a while, so I'll be back when it's finished. Okay, it's done. Now you can check if all files have been placed into the right folders. Let's take a look at the JSON file. Here, all download infos are stored, and if you want to skip some files, just remove that section before running the script. Now unzip the images file. You will need the ControlNet images for the second workflow, but you can also use my input photo and the walking animation if you like. Now let's upload the starting image and run the workflow. If you get an InsightFace error, there's something more we need to do. Let's get the InsightFace 3.11 wheel from its GitHub page, linked down below, and put it into the ComfyUI update folder. Then open a command window there and run the command that you can also find in the description. That will take a while. Then restart ComfyUI and we're good. Let's now test the second workflow. Upload the ControlNet image and run. Good. Now the third one. Install the missing nodes. I found an error there. Don't install the inference core nodes as recommended, as they didn't work with me, but install the auxiliary preprocessors instead. Then restart ComfyUI. It will take some time to install these nodes, so please be patient. Okay, now upload the walking animation and run. I've restricted the workflow to 16 frames in the load video node, so it won't take that long for testing. Still, it might take some time, because some more models may need to be downloaded. Okay, seems to work, so I've covered everything I wanted. If this tutorial was helpful to you, please leave a like and maybe consider subscribing. Thanks for watching. I'll see you in the next one.